Okay, so this is 4.1, B as in boy, buffalo, bicycle, bimbo, and looking at example 3, shifts of functions. Okay, so let's look. I'm going to make this a little bit bigger here. Let's look at what we've got here on the equation. They give us this here. They give us f of x is the square root of x. Then they tell us that g of x is what f of x is, but within the radical sign we're going to add 3, and outside the radical sign we're going to subtract 4. Now if you look at the vertical and horizontal shifts of graphs in green in your book under 4.1, vertical shifts have to do when your original function, when something is added or subtracted to it. So in this case it's -4. So we know we're going to have a vertical shift because we have a -4 here. And that vertical shift, according to the rules, we're going to go down 4 from the original place here. Okay. It also says that the horizontal shifts of graphs, if within the radical sign, and in the other one we had absolute value signs, but in the radical sign, if there's an x there and we add or subtract a number to that x within the sign, it's going to go left or right, positive or negative. And we said that if this is a plus sign, it will shift to the left this many units. So if we have a graph, and I'm just going to stick a graph on here. This is not going to be accurate, but just to make sure you understand. If I have a graph that looks like that, okay, according to what I have here, it says it's going to shift the -4. It's going to shift, the whole thing is going to shift down 1, 2, 3, 4. Okay, but it's not only going to do that, it's going to shift to the left. How many? 3. So it's going to shift another 1, 2, 3 over here. So now it's going to go down here and then this way and end up being like that. Okay, so see what happened there? Two things happened at once. It shifted because of the +3 and it shifted because of the -4. So if you graph the square root of x, then you can graph this here just by shifting it the way it's asking us to do that. Okay, so what relationship do you notice between the two graphs? Well, it's just that things shifted between those two graphs. It shifted left 3 and down 4. Now, what you can do, and what the book shows as an example, is they would take the information. Let's make this bigger here again. They took the information originally and just plugged some numbers in for x. Just a whole bunch of numbers. Okay. Then they took the square root of those numbers. So there's your x and there's your f of x, your y. And that's what they graphed first. 0, 0, 1, 1, 2, square root of 2, and they got this blue graph. Then they took this other equation here, or function, threw in some numbers for x, plugged them into here, so -3 plus 3 is 0, minus 4 is -4. And they got those, and they graphed those, and they got that graph right there. So you can plug numbers in and see what these two graphs are, but you can also just look at what you've got here and what we talked about earlier. Left 3 units, down 4 units, we're going to get this graph right here. So you just take your vertex or the starting point here, move it over 3, down 4, and you've got your point. And do that with all your points, and you've got your graph right there. Okay, so let's look at example 4, profit. All right, so there's our original equation here. You know, we've already worked with that a little bit. They give us one that looks like this. Okay, so what do they tell us? They give us a negative here. Remember, when that's negative, we know it opens down. Okay, we know because this is squared, we've got a quadratic, we're going to get a parabola. So it's going to look like this. This tells you whether we're going to shift left or right. Because it's a minus, we know we're going to shift to the right 55 units. And because that's a 4,500 and it's a positive, it's going to go up 4,500 units. Okay? So obviously you can't graph that by just doing this. You can use your calculator and graph that and get the information that you need in order to get what you want. All right, so like first of all, how many elliptical machines must be produced to yield the maximum monthly profit? Well, it's going to be at this vertex right here. That's going to be the most, which in this case is going to be your vertex, 55 and 4,500. Okay, so you know that at 55, 4,500 on the graph is going to be where you're at. So that means 55 ellipticals and 4,500 is how much profit you'll make on those. So that's the maximum amount of money you'll make off these ellipticals. You need to sell 55, you'll make $4,500. That is the maximum monthly profit. So pretty much that's what we've got there. So what I'm going to have you do is look at example 5, just read through there. They give you an equation, f of x equals 4.947 times the quantity x plus 10 to the 0.495 power. Nothing's going to shift there. Okay, you're not given a standard equation. You're not given, let me get my pen here, an f of x equals, say, x, and then they change it in the next one to x plus 5 minus 3, because then you're comparing that one with this one, and therefore, you're shifting it here and you're shifting it here, and they're not giving you that option in that. So go ahead and read through that, and basically the graph is just going to be the same. All right, so let's look at stretching and compressing graphs. Basically, that just means making it wider or making it skinny. And that will depend on what, let me get the equation up here again. One of the things is when you write these things, so often you start memorizing everything, and hopefully, you recognize what you've got there. Okay, it depends on what that number is, okay? The bigger your A is, the skinnier your graph is going to be. The smaller this is, as it approaches 0, it starts getting fatter, okay? Once you get below 0, then, whoops, I don't want to do that. Remember, if that A is negative, it flips it upside down, okay? So we're not interested in whether this number is negative or positive as far as how fat or how skinny this graph is. The positive and negative flips it over, but we are interested in how small it gets, because the closer it gets to 0, the more stretched it gets, okay? And the bigger it gets above 1, the bigger it gets, the skinnier it's going to get. So if you look at the bottom of page 250, it gives you a graph of f of x for A, 2 times f of x, which is a 2 in here for the A. Or the last one is if this was 1/2, and notice how it's the fattest. So that's going to tell you what that's going to do as far as stretching or compressing. So maybe to help you remember this, you might want to copy down table 4.5, just so you remember that the number in front, your A, is going to get skinnier or fatter, depending on what number that is. All right, so let's jump to reflections of a graph. And that pretty much is whether or not, and this stuff here can get a little tricky. So I'm going to start another video here shortly. But the reflection of a graph is basically, if you've got a graph here and you have a parabola, if it's reflecting, it may well, let me draw another graph. That one isn't going to do what I need it to do. All right, so you got a graph here, and you've got a parabola. Okay, if it reflects across the x-axis, it's going to be the exact same parabola, but it's going to be mirrored across here. Okay, if you want to mirror it across the y-axis, it will just go across here and be the exact same. And so let's look at reflections here, and let's see, I'm at 10 minutes. I'm just going to go ahead and talk about that for a minute, and then we'll jump into a third video. Okay, so let's look at what we've got on page 251. Okay, so we have x and y equals x squared. So we put a negative 2 in here for x. We square it, and we get a positive 4 for our y. Okay, so we've got this parabola is showing up right here in blue. Now, if instead we said that y equals negative x squared, so instead of saying it's x squared, we say it's negative x squared, we take negative 2, okay, and we put that in for x. So negative 2 times negative 2 is 4, and then we take the negative of that, and that gives us a negative. Okay, we take negative 1. Negative 1 times negative 1 is 1. We take the negative, we get that. We take 2. 2 times 2 is 4. Put the negative on it, we get negative 4. And notice what happens. This case, we get the red graph. I'm not really sure why they show both of these. Maybe they explain that down here. But anyway, you get a reflection across the x-axis. So when y equals x squared, you get one graph. When you put a negative in front of the x squared, you get a reflection across the x-axis. Okay, let's look down here. This is y equals x cubed, this blue, okay? It's not two parabolas. It's this funny shaped thing right here. Okay, that's x cubed. Now, okay, so we graph that, and that's what our blue is. Now when we take numbers and put in for x, but instead of a positive x cubed, we have a negative x and cube it, we get the red one. So notice what happens here. It reflected across the y-axis. Now notice the difference here between this one and this one. Here there's a negative in front of the x squared. Here there is a negative within the parentheses with the x. This negative is attached to the x. This one is in addition to the x. So that's a key thing to remember with your parentheses there. So you square the x, then you put the negative on it. Here, you cube the negative x. So if we put a negative 2 in here, negative 2 to the and negatize it. Take a negative of that negative 2, that gives me a positive 2. 2 times 2 times 2 is 8. Let's say we put this 2 here in for x. We put a 2 in there for x. Now we have negative 2 cubed. Negative 2 times negative 2 is positive 4 times negative 2 is negative 8. And we end up with this red one here. So I hope you see the difference between the negative here in with the x and the negative here outside the x. Okay, so that's what we have here. Now let me pull this up a little bit if I can grab hold of it here. And they give you some really, really important stuff here when it talks about reflections. Because you need to know, is it going to reflect across the y-axis like this? Or is it going to reflect across the x-axis? So the graph of y equals the negative function of x can be obtained by reflecting the graph y equals f of x across the x-axis. And the graph of y is f of negative x can be obtained by reflecting the graph y equals f of x across the y-axis. That is very, very confusing. Therefore, we're going to look at some examples and kind of help you get what's going on there. But I would especially write down the green information of transformations on page 252, where they give you vertical, horizontal, stretch and compression and reflection. And again, we'll go over that reflection here on this next video, because that can be a part that's very hard to understand. And in fact, when we get to symmetry in a couple pages, you're going to need to know that. So anyway, next video.